Dayang,
Yes, sir.
are you from Sarawak?
No, Sabah.
You're from where?
Kota Kinabalu.
Oh, sometimes some people also from Sarawak, Dayang. Hello, Dayang.
Yes.
Oh, Dayang. So what does the Dayang means?
My
Dayang di
Dayang
sana.
is a family name.
But there are so many Dayang. Do you know Dayangku Intan, Dayangku Hasana?
Yes, it's how to say, it's from a different root. Like we have Pangeran, we have Dayang, Dayangku, Awangku.
Oh, Dayangku is my Dayang lah. Dayang is some people's Dayang.
Mine is Awang Dayang.
Oh, I am unaware
My
about
dad
this
is
thing.
Awang.
New knowledge for me. Dayangku Intan, Dayangku Hasana was my classmate, but she is from Sarawak. So I thought Dayang is something like Bajau, Minangkabau.
Oh, my Dayang is from Brunei because my great grandparents are from Brunei.
Uh, Azim Sofi.
Yes, sir.
Okay, Alhamdulillah. So only a couple of people are absent over here. Allow me to share my.
Sir, you
Yes,
didn't
sir.
mention my name.
What's your name?
Zetirania.
Hmm? Your
Zetirania.
name is Izwan Fazri. Nur Shidatul Afiza.
Yes, sir.
Zetirania.
Nur Irdina. It's okay, sister, because I call names random, by random, just to
Oh,
make sure people are here. But some people they on and they go somewhere, Bulan Pasir. We should go to Ramadan Bazaar. And before that, let me. Can you hear me? You can hear me. I want to share my. I want to share my screen first of all. I want to share my screen. If you can't see, let me know. I believe that you can see my screen.
yes, sir.
Okay, Bismillahirrahmanirrahim. My humble apologies for being absent. For last Monday, was absent. Last Monday, I don't know what is the date, but absent. Wednesday, we had a class. We had concluded chapter 2, and we have to have a quiz 2 on Tuesday, but people asked to be postponed. So, inshallah, we'll have quiz 2 on chapter 2 on Thursday. Okay, I hope that is fine. Uh, and then we finish chapter 1, we finish chapter 2, and we want to start chapter 3. Before starting chapter 3, I have given a couple of books. Number one is to look at data path architecture lecture, video lecture on YouTube by Prof. S. Rahman, not Rahman, Rahman from IIT Madras. This is here's a list of about 20 video lectures on computer architecture and organization, not microprocessors. So he will not be talking about microprocessor in specific, but he'll be talking about in a general microprocessor. So particularly, I want you to look at data path architecture, lecture. Data path architecture is basically data path architecture means how data, so data here means code and instruction moved from memory, because you know that when the programs or the softwares program basically are converted or encoded into binary code, and binary code is loaded into main memory. From main memory you will the CPU will read one by one, put into CPU and execute. So there is a path that it follows, and this is not random, or automatic, but indeed it's a controlled sequence of events. So what we mean by events is hardware events lah, hardware related events, that pull the data means your binary code will be transmitted on external bus, on internal bus, till it has been executed on ALU. Okay, so this is controlled by whatever is known as control path architecture. We already discussed about this, but I just wanted you to look at this to have more idea, where you'll be talking about registers, you'll be in detail. Okay, so my exams will not comes from here, but this is just to fine tune your okay lah. If I don't you give you work, we will include in quiz number 3. Okay, we will include on quiz number 3, which is processor activities. Okay, and basically the data path architecture we have seen uh, many times. This is ALU registers connected to internal bus, and bit connected to register file. Coming back here, result flag flag 230 flag, and data and control signal flows from control unit. This is the basis of data path architecture. But we say this is not by chance. So if you look at that lecture, he will show you some good how to organize this thing, how to this thing has been organized. Data path architecture is a subject of computer architecture. Okay, that is one we will have to say. And data path architecture, it is not fixed, it is microprocessor dependent, and also depend on instruction depends on what the software we like to do. So basically he'll be talking about how data move from memory, from instruction register into control unit, into different type of registers, which registers going into, when it will put into ALU, the result, what happened in the result coming out will be part of this item. So to go more in detail on instruction, example of instruction is move AX, comma BX. This means copy content of register BX into AX, register AX, and this means that this is x86 family instruction set. Instruction set. Instruction set means group of assembly language. So we can go more on detail on instruction set, but we reserve that for chapter 7 when we want to discuss about software model. Okay, next is we wanted to say that the move AX comma BX is divided into two parts. This is known as opcode or generally known as code. This is known as operand, generally known as data. So we have source operand, and destination operand. Then this comes to question, is this format fixed? No, this is not fixed. As we say, this is microprocessor dependent. It means A088 will have one format, higher processors have another format, and we have ARM in a different format and different languages. Different languages. And our data path architecture uh, depends on this instruction. This is what you wanted to do. This is what you want to do. Computer is your slave. Computer is your slave to execute your program. Okay. So sequence of instruction is known as software. Okay. Leaving the data path architecture. Number two, I also have asked you to do some case study on registers. On registers. So what I want you to do is what are the registers in Intel 8088 Pentium registers, and also 64-bit, for example, i3. So I'm not giving specific i3, any i3, maybe the old i3. So 8088 is a 16-bit registers. Pentium processors are 32-bit, so registers are also 32-bit. What do you call Intel core processor, i3 processors are 64-bit. So what is the expectation that we can have from here is, if this is your 16-bit processor, this is 16-bit processor. Uh, Example, there are many, known as AX, One of the registers is known as AX. Then comes 32-bit processor. So this is 32-bit processor. Sorry, 32-bit processor, 32-bit register. And now the name is changed to EEX. EAX. This is Intel concept for registers. Yes, I just wanted you to list what are the names available, not the function. And when it comes to 64-bit, so now we have 64-bit registers. So entire thing is 64-bit registers. What is this is known as RAX. Look at the name has been maintained. AX from day one to indicate they have the similar function, but the capacity has been increased. Capacity increased from 16-bit, 32-bit to 64-bit. The even 8-bit registers as well, known as AL, known as AL, 8-bit registers. Okay, I want you to list it out and also compare with ARM microcontroller. There are many series of ARM microcontroller. Asking you to list the ARM registers is like asking you to list the Intel registers. So ARM is very general. ARM7 is one of the microcontroller widely in use, and you will see the naming culture differ from Intel to ARM. If it's Intel, I have AX, BX, CX, and so on, which we have discussed earlier. ARM will have R0 until R13 with a few more registers, special purpose registers. I want you to do that. Number three, please also look at to a YouTube lecture on 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 control unit design. Control unit design. This is more to chapter 2. This guy from Geek College or Geek something, he'll be talking about control unit. I prefer this one because he physically draw the control unit, control unit, either hardwired, not hardware, hardwired control unit or micro programmed control unit. Just to revise a little, hardwire control signals are generated from hardware logical circuit. Okay, like if this is a CU control unit hardware, inside there are so many logical units over here. Depends on what you wanted to do. Microprogram control signal, control signal start in program, start in a memory, in memory. So he will show you that. And then since this is hardwired, this is fast, but cannot, not changeable, cannot, I would like to use the word cannot, or cannot change, cannot change. This is little slower. Whenever we come to talk, whenever we are talking about computer architecture and microprocessor, I always have a question: how fast is the fast, and how slow is the slow? Okay, little slower, but changeable, upgradable, changeable and upgradable. Here, this is applicable on RISC type of computers, or this is applicable on CISC types of computers. CISC. So this is reduced instruction set computers. This is complex instruction set computers architecture. So reduce means I can only normally I just settle everything in one instruction. So here we have multi-level instruction, multi-level instruction, basically more complex it is. This is most commonly found because you're talking about today's technology is based on micro program computer architecture, micro program control unit. Okay, talking about risk and CISC architecture, when we're talking about architecture, I think this is a suitable place to introduce Van Neumann architecture versus Harvard architecture. Van Neumann versus Harvard architecture. Okay, can I take 1 minute break? I'll be back. 1 minute only. 2 minutes. 3 minutes. So yeah. Kalau ma, Bismillahirrahmanirrahim. Just a quick go through on when Newman and Howard architecture. You see, in second chapter, when we talked about when we discuss about the components of a computer system, we have shown the computer is actually made. The CPU is connected to memory, something like that, right? And we also have seen the CPU versus processor. In our arguments, we have mentioned from the diagram they look same, but if you look from broader visualization or broader item, CPU consists of multiple core plus FPU plus GPU plus cache and so on. But the process is processor, single processing unit. Single processing unit. This is one definition that we have seen. Now, talking about the CPU and memory, how when Newman architecture and Howard architecture shows us how the memory is organized. I mean that we have instruction, we have code and data, or we see code opcode and data operand operand, or we have instruction and data. I always dislike to use the word instruction. You have to be specific what we mean by instruction. If you are referring the instruction to the opcode, then it's opcode. It's not instruction. Instruction refer to instruction. Instruction refer to the what you call something like this: move ax comma bx. This is what known as instruction. Furthermore, the instruction is divided into code, opcode and data. So this is more specific term to describe, and so some books or some references uses instruction to describe the code, which is not acceptable. So what when Newman and Howard architecture, Van Neumann and Howard architecture. In Van Neumann, compute CPU is connected to main memory only once. I have one piece of memory and one piece of CPU. One piece of memory. In Howard, the memory is divided into two. One memory is for the code or instruction, and one no memory is for data instruction. So to store the everything instruction. So how does it looks like? If I have a CPU, my microprocessor is connected to memory, data memory, and I have another resources connecting to instruction, or that not code instruction, and instruction could be code and data. So this is how Howard architecture looks like. So to talk about the advantage, some people say this is speed. So again, when you come to speed, how speed is the speed, how speed is the slow, how slow is the slow. This is what people cannot answer. Many references when I look at it, was not able to answer this question. Generally, it was put speed. Generally, it was put slow, low. Why? Because in environment when human, I have two bus cycle to access instruction. My question is this valid? That depends on your instruction. Is your instruction part of data, or data is not part of instruction? And some say this is one bus cycle. These are some generally general differences that you could see on Van Neumann and Howard architecture. So this is your assignment number three. Right? Assignment number three. Assignment number three. Yeah. Yes, assignment number three. Assignment number one is look at the 50-minute video lectures from Professor Rahman. Assignment number two, just scribble on your notebook. Notebook, not to submit about the registers. Assignment number three is to another video lecture. Assignment number three is another video lecture on control unit. Control unit by someone on Geek, I think. Maybe I can send this URL later. Number four, I want you to find the differences with Ben Newman and Howard. Please do not repeat what I scribble over there. Uh, Howard. When I was talking about this, some student asked, is this Howard referred to the Harvard University? The answer is, I'm not sure. I'm sorry, I don't have that information. Okay, so this provide some kind of a link from chapter 2 to chapter 3. Chapter 2 to chapter 3. Chapter 3 is about processor activities. We will look at more detailed technical information on how computer works, on how CPU works, on how CPU works. Huh? If you have time, this is not you can read a blog, how stuff work and look stuff works and look for microprocessor. A couple of pages they talk about how microprocessor work. So we will look at that in more detailed information. More detailed information. Talk about the processor activity. We should start from this question: what a CPU has to do with memory? What a CPU? So to answer this question, we like to look at some of the processes that the CPU do. Memory, number one, is what we call a read cycle. Read cycle. 1 minute. I'll be back. 1 minute. Bismillahirrahmanirrahim. So we wanted to look at what is a CPU's business with memory. So what I'm trying to do is we wanted to approach from top to bottom approach. So the first business is what you call recycle. I would like to say the microprocessor fetches data from external resources. External sources. So what we mean by external source is if this is fetching data from memory, then we call it memory read cycle. Read cycle. If it fetch data from input output system, then we call it input output read cycle. This is one whole thing lah. So we have to understand few things over here. Number one is what we mean by the microprocessor. What is we mean by the fetching? What is fetching actually? What is the physical phenomena happen when the microprocessor fetch something? And we call data. So what is data? Is actually about data. And we call it data, binary code, binary code from data. So the fetching is a very big process over here. And then when you talk about memory and input output, they are same process, but they are different signals are involved over here because we are like reading from memory and reading from input output with different things. Read cycle, and this is our core discussion on chapter 3. Okay, read by cycle, that is how microprocessor work, which we will go in detail of fetch, decode, execute, and also state diagram. Number two is what you call right cycle. Right cycle. Again, the word comes what is right, what is cycle. Writing is a phenomena. What phenomena? What are the sequence of event happen to the microprocessor signal during a write cycle? It's a very long process to do. Again, the microprocessor sends data to external source. So again, we can say memory write cycle, input output write cycle. So we have one, two. three of cycles that we already discussed. So memory rate cycle means the microprocessor sends data to the cycle. This is for storing purposes, and this is for controlling purposes, control purpose. For example, like light, LED, sound a speaker, rotate something, rotate motor. So rotation of a motor creates movement in the rotating. If no move, creates movement. So these have two businesses we have discussed: read cycle, the microprocessor fetch data from external sources. The external sources identify that memory or input output, and then we have write cycle. Microprocessor sends data to external sources. We have memory. This is storing purpose, and this is like reading. This is for execution purpose. And number three, we have interrupt service routine. Interrupt service routine purposes. Service routine purposes. There are many. What do you call? There are many things that the CPU do with microprocessor do with the memory, but these are the among the basic things. So interrupt service routine. This is a study of a microprocessor where you want to know what is interrupt, what is the service routine. Service routine. Interrupt is a request from either software or hardware to utilize the microprocessor. Okay, you want to stop the current execution program, whatever the microprocessor is doing, to ask for some permission from the microprocessor. Service routine is the feedback or response of the microprocessor towards the interrupt towards the interrupt. And of course, this is also a very, not to say very detailed process. For example, just in ISR number 20, what the microprocessor is supposed to do. ISR number 22, what the microprocessor is supposed to do. And what is the meaning of ISR 20? And this study is not complete without microprocessor, and this is microprocessor dependable process that depends on the microprocessor. In this course, we are more interested in memory read cycle. Memory read cycle, you wanted to know how instruction are read from memory for execution purpose. Execution process. We will be concentrating more on memory read, not on decoding and execution. Decoding is a story of control unit. When you look at the YouTube lecture that I asked you to do, they will show you the decoding process itself. Okay, going ahead with what's the time? Going ahead, going ahead with this thing. Then we have few more definition that to make as a basis of study. That is the meaning of clock cycle. Meaning of clock cycle. So this is speed of a microprocessor. Speed of microprocessor measured in hertz. So we can say historically we started from kilohertz. This is 1960s, 1970s to megahertz in late 70s. Then until gigahertz we started 80s. We already got gigahertz ready. So some microprocessor works on kilohertz, megahertz, and some microprocessors on gigahertz. Look at the timeline. Timeline moving from kilohertz to megahertz to gigahertz. The microprocessor goes through massive changes in software in terms of operating system, programming, and so on. Hardware in terms of internal bus, external bus, RAM, how this is supposed to be connected to. So we cannot discuss everything in detail. So we look at in general. So clock speed. So one bus cycle. I would like to say that one bus cycle consists of one clock speed. Next, we want to look at what is bus cycle. Bus cycle. And how does the before that clock microprocessor got his clock speed? Generally, if in the case of 8088 example, pin number 31 and pin number 32 are connected to what is known as oscillator, crystal oscillator, crystal which oscillates with non-stop, and the data this is analog, this is analog, this is digital. This is the crystal, the oscillator is analog, and this function of this IC is to change it to digital, and digital data will be passed to pin number 31 and pin number 32 as a clock cycle, where the 8088 will take the input of 31 and 32 and use it as for its purpose. Okay, next we wanted to look at the definition of bus cycle. Bus cycle versus instruction cycle. This is just a definition. Bus cycle, the time required. Am I still connected?
Yes, sir.
Uh, we are getting more technical. We are getting more technical. So please write in your notebook. That's why I asked you to write a notebook. You can write all your homework. You can scribble in your notebook, edition's notebook, so that you will see the flow of the lecture going on. Okay, how the flow of the lectures are going on. So again, coming back to bus cycle, time required to make a single read or write transactions. So time required to make a single written transaction between what? Between microprocessor and memory or input output, but we are more focused on memory. Nah. So what is this story? What is this about? Okay. So again, time required to make a single read or write transaction between microprocessor and memory. So what is this trying to say? We will continue that in 1 minute. I want to take 1 minute break. அது வந்து டெக்னிக்கல் சரியான டெக்னிக்கல் இது நான் சொல்லிக் கொடுக்குறது. காடி முன்னால் உள்ள ஜாமான் கடையில் வச்சுட்டேன். எனக்கு வந்து அந்த மற்ற விஷயம் உள்ள வச்சுட்டேன்னா போதும். அவன் ஜாக அவன் சொல்லிட்டான், நீ வந்து போடக்கூடாது, மியூசிக் இருக்கு, 2 வாட்டி நீங்க போட்டு போயிட்டேன், நான் காட்டி கொடுத்துட்டேன், அப்புறம் வந்து மியூசிக் எல்லாம் கூப்பிட்டு வராங்க. அவன் நீ வந்து வரும்போது பாபு சொல்லிட்டு நான் காசு கொடுத்துருக்கேன், நீ போட்டுக்கலாம் 6 மணி நேரம். நீங்க என்ன செய்ய போறீங்களா? இன்னொரு கொஞ்சம் ஒரு பேக்கெட் இருக்கு. இல்ல அதுதான் காலையில குடிச்சோம். குடிச்சீங்க, அதுக்கப்புறம் பேலன்ஸ் மூடிச்சு, மூடிக்கிட்டீங்க. நல்லா இருக்குமா இது பரவாயில்ல மூடி வடியோரம் தண்ணி வச்சா எனக்கு ஒரு பேக்கெட் போதும் உங்களுக்கு. அஞ்சு நம்மளுக்கு அக்கா பொண்ணு அதுக்கு ஒன்று செய்யணும். உளுந்துலாம் வாங்குறீங்க, அது எவ்வளவு வந்து நேற்று நான் என்ன சொல்லுங்க. செலவு 200 வருது. ஒரு வாட்டி கடைக்கு போய் 100 வருது, 60 வருது, 100 கடைக்கு போனா 100 வருது, 60 வருது. 200 நீங்க போய் கடையில் வாங்கி தருங்க. நீங்க ஒரு सब्जी आपको सब्जी हुआ ड्रैगन फ्रूट जम्बू मैंगो वांगना चराई वांगना सांबार लेके ओ அது அங்க 30 அப்படி டிக்டாக்ல வந்து இதெல்லாம் பாக்குறாரு சாப்பாடா பர்கர் you must send the you should read Quran, not look at TikTok. Alia should read Quran. நைட் வந்து கொஞ்ச நேரம் தான் இருக்குது இந்த மாதிரி இது நோம் தரக்க பிரிப்பேர் பண்ணி எடுத்து தெரிஞ்சு அது கோடி semoga Allah merahmati. Assalamualaikum. People are still here?
Yes, sir.
Yes, sir.
Okay, alhamdulillah. So we are moving into very deep technical detail. We have seen, if you look at the video lectures, you will see what I mean. And I'll try to update today whatever notes I have, lecture notes, video lectures, and everything into the website. So we talked about the bus cycle, meaning time required to make a single read and write transaction between microprocessor and the memory. So this, when you talk about read, this is a read bus cycle. When you talk about write bus cycle. We know well that our program, for example, move bx, one example, and why always move is an example only, can be anything. And so why always move is encoded into binary codes B80102 example, and then this is pushed into memory And we have mentioned that until this is software, and this is hardware process ready, hardware process. So, and we also have mentioned in 8-bit memory, 8-bit length memory, and if it's a 16-bit addressing, example 0100, 0101, 0102, 0103. So it will be loaded into B80102 example. And so now this is the instruction must be read from the memory into the microprocessor for execution. So the address is connected to address buses. The address is connected to address buses. Data is connected to data bus. And so we have CPU, address bus goes somewhere, data bus goes into instruction register. So again, when we talk about the buses, we discuss what is the size, and from the address over here in this example, we have address bus is 16-bit. This is 16-bit addressing, and let's put our data bus has 8-bit, 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 so that I can read one memory in one bus cycle. So I read V8. Time required uh, to read the V8 from the memory into the CPU is known as bus cycle. So from here I say one bus cycle, I read 8-bit. This is what known as word. This is known as word. We have mentioned that the term word must be misleading, but the word over here means how many number of bytes that you can read in one bus cycle. Okay. So in this example, I'll read three bus cycle, where in the first bus cycle we read V8, in the second bus cycle we read 01, third bus cycle we read 02. This is the bus cycle mean. Let's take another example. Example 2, if my data bus is 16-bit, then I can read my word is 16-bit. I read B801, B B801 in one bus cycle, and I read 02 in another bus cycle, two bus cycle. So in this example, generally we have shown you that the what do you call the higher address bus, we can store more information, and the wider data bus, we execute faster. This is the evident three bus cycle and two bus cycle. And of course, two bus cycle is executed faster than three bus cycle. If one bus cycle is 1 GHz, then three bus cycle will require 3 GHz. Two bus cycle will require 2 GHz. Same data, but wider data bus. Okay. Then how about instruction cycle? Instruction cycle. Number two, instruction cycle. Instruction cycle is time required to read or write. So you're looking at reading and writing only, not execution. Time to read or write one instruction, one instruction, one instruction. And furthermore, I could say include reading or writing, decoding, and also execution, execution of one instruction, of one instruction. Example, we have moved ax comma bx. We set example. This is converted to 0203. So time required to read, decode, execute, which is known as fetch, decode, execute cycle, is known as instruction cycle. And this is, we have another cycle which is known as mission cycle. Mission cycle. And most commonly, I find that the term mission cycle has been confused with instruction cycle. Okay, mission cycle confused with instruction cycle. I would like to say the mission cycle is time to read or write one instruction, not including decoding and execution. I would like to give these three definitions. So we have bus cycle, we have machine cycle, and we have instruction cycle. Cycle means one period of time that is known as cycle. One bus cycle is one clock speed, one clock speed. So cycle means period of time. So we have bus cycle means time required to read only one single read or write transaction. Example we have given over here. Instruction cycle means time required to read, including reading, writing, coding, and execution of one instruction. And we have mission cycle, time to read or write one instruction without including decoding and execution. And most commonly, we find the instruction cycle and mission cycle has been misnomer and confused together. So next, we wanted to talk about how microprocessor work, and we want to talk about read cycle. What actually happens in memory read cycle? So we can look from fetch, decode, execute. We can look from state diagram, or we can look at timing diagram. Timing diagram is the study of microprocessor, so it needs details of these signals. So if we have time, then we will reserve it for chapter 9. Else we will look at fetch, decode, execute, and state diagram only. Okay, so I have to continue in my next class on Wednesday, and I am excited to see you on Wednesday, inshallah. Although I'll be scribbling on my on tab, and you'll be looking at the thing. I have not breakthrough yet how to display from the tab to projector yet, because I've been not well for the past 1 month, more than 1 week, 1 week. I went to the doctor on Saturday. Getting better lah. By the rate of I'm getting better, inshallah Wednesday should be okay. So with this, selamat berbuka puasa. Don't eat a lot, and what do you call uh, don't forget your Maghrib, Isha in Jama'ah, and do not forget Tarawih. If you can go to the Tarawih Masjid for Tarawih, that will be good. If you cannot go to the Tarawih, you want to pray 8 rakat in your room with your friends or so on. Okay? You can read Al Quran with your handphone in your hand. If there are some Hafiz among you, you can appoint them as your temporary imam. Sisters, don't select brothers as a imam. That is a different term already, yeah? Okay, Assalamualaikum.
Salah, thank you, sir.
Okay,
Okay,
sir.
sir.
Thank you, sir.
Waalaikumsalam. Thank you, sir.
Thank you, sir.